Now we are going to study question 1 from the our book, question 1 from the our chapter 1. So give the heading first of all, chapter 1, question 1. It is from what? July 2010 exam, question 1. So before going further, everyone give the heading of the question, guys. Everyone give this heading, chapter 1, question 1, July 2010 exam, question 1. Now guys, everyone try to see the scenario here, what we have to do. What is our target in A part? In A part they are asking us what? PV and TS diagram. What they are asking us in A part? Our target in A part is what? Pressure volume. PV stand for what? What is the meaning of PV? PV stand for what? Pressure volume. And TS stand for what? Temperature entropy diagram. So A part target is what? Guys, everyone, what we have to draw in A part? We have to draw what? Everyone? PV diagram. And so we have to draw pressure volume diagram and TS diagram. So before going further, before writing down any given things, generally we will follow the standard practice in every question generally. So we will leave the space for the PV-TS diagram by drawing the coordinates of the PV and TS. Instead of saying coordinates, we will say drawing the axis of the PV and TS. So, and generally we will say generally, it is not a compulsory rule. So generally we will try to draw the PV-TS diagram side by side. What we will do? Generally we will try to draw the PV, pressure volume, and temperature entropy diagram. What guys, everyone? Side by side. Generally, it is not a rule. If you have a proper space, you can do side by side or one below the other. But generally we will try to draw the PV-TS diagram side by side. That's why I am saying generally. So everyone, before going further, draw the axis of the PV and draw the axis of the TS, guys, everyone. So please complete this discussion and leave some proper space, guys. So please everyone, complete this one. Now guys, I'm going to read the question carefully with you. So please everyone try to see the scenario. Here we have what? Air at a pressure of 1 bar. So this is what our initial condition. So we have what? Air at a pressure of 1 bar. So this 1 bar will become which point pressure? This 1 bar will become our point 1 pressure. So P1. Air at a pressure of 1 bar and a temperature of what? 300 Kelvin. So initial pressure and this is what? Initial temperature. So T1. Temperature 1. Temperature of the initial point means T1 is compressed. So what is there? So this pressure air and this temperature air, this pressure and temperature air is going to do what, guys? Everyone is going to do in what? Compression. Is going to do in what, guys? Is going to do what? Is compressed in an engine cylinder. So what is going to happen? Compression of the air takes place in what? Everyone in engine cylinder arrangement. And what is their initial volume? From a volume of what? 0.3 meter cube to a volume of 0.02 meter cube. So 0.3 meter cube will become which point volume? V1. And 0.02 meter cube will become which point volume? V2. Means we are going from 1 to 2. So what is process 1 to 2 will be here, guys, everyone? Compression. What is happening here? First of all, compression is happening. What is happening here, guys, everyone? Compression is happening. So compression. Now then they are saying further index of compression. Now they have given us what? Index that associated with this compression. That index of compression is what? 1.52. And what, by which symbol we denoted index of compression? If you remember, we have seen total 5 processes. First of all, constant volume process. This is constant volume. Then we have seen constant pressure process. Then we have seen isothermal process. Then we have seen isentropic process, and at the end we have seen polytropic process. And in which process we have used the word index of compression. So if you remember our discussion, we have used index of compression or index of expansion in a polytropic process. If a process is a compression process, in that case that polytropic index we will say index of compression. If that process is an expansion process, if that process is a polytropic expansion, In that case, we will say index of expansion. But here in this case, guys, everyone, if you remember, if you see this question, what is there, guys, everyone? Index of compression. Why they have given us an index of compression? Because this process is a compression process, and index of compression is related with which process? Out of these 5 processes, guys, everyone, constant volume. See, we have seen 5 processes. First of all, constant volume. Second one is what? Constant pressure process. Third one is what? Constant temperature process we have seen. Fourth process we have seen isentropic process. And fifth one is we have seen polytropic process. So in which process this index of compression is applicable? So if you remember, just now we have seen this relation is index of compression is applicable to what, guys, everyone? Polytropic process. So here we are doing a compression is what, guys, everyone? Here we are doing a compression is what? Which compression we are doing? Polytropic compression. So here which process is applicable? I am going to erase all this process. So here we have a first process is a compression. But which compression is that one? Polytropic compression. And how does we come to know that it is a polytropic compression? Because here they have clearly mentioned index of compression, and index of compression is applicable to what, guys, everyone? Polytropic process. So that's why here it is applicable to what, guys, everyone? Polytropic process. So now, guys, everyone, before going further, try to see the scenario here. See. So now, guys, everyone, try to see the scenario here, what we have to do and how we are going to approach the further, guys. So here, what is process 1 to 2 we have? Process 1 to 2 is what? Here, after the PVTS diagram, always leave 1 or 2 line and try to draw the things neat and clean, guys, everyone. So what is our first process here? So what is our first process that we can write down, guys, everyone? What is the first process that we can say? Process 1 to 2 is what, everyone? What is process 1 to 2? Polytropic compression. What is first process, guys, everyone? Polytropic compression. That is what a PV, we denote generally polytropic process by what? PV raised to the power n, and n is how much here? This index of compression is what? N. So n is what? PV raised to the power 1.52 is equal to constant. So whenever we want to denote polytropic process, we denote polytropic process by what, guys, everyone? PV raised to the power 1.52 is equal to constant. Then I'm going to read the question further, guys, everyone. Heat is then supplied at what, guys, everyone? Heat is then supplied at a what? Constant volume until the pressure is what, guys, everyone? 80 bar. So after polytropic compression, what is going to happen, guys, everyone? After polytropic compression, what is going to happen, everyone? Heat is then supplied at a constant volume. So after the polytropic compression, what is going to happen? Heat is supplied at a constant volume until the pressure is 80 bar. So we are going from what? In process 1 to 2, we have done polytropic compression. In process 1 to 2, process 1 to 2 is what, guys, everyone? Process 1 to 2 is what? Polytropic compression. And process 2 to 3 will be what, guys, everyone? What will be the process 2 to 3? What we can say? Constant volume heat addition. What is process 2 to 3 here, guys, everyone? Process 2 to 3 is what? Constant volume heat addition. What is meant by constant volume heat addition, guys? See, here see. We are saying heat is then supplied. Heat supplied means what? Heat addition we are doing now. What is the meaning of what? Heat supply. We are supplying. We are supplying heat means what? We are doing the heat addition. So process 2 to 3 is what? Constant volume heat addition. So in this way, in this question, we have what? How many processes here we have, guys, everyone? Here we have a 2 process. First of all, 1 to 2 is what, guys, everyone? What is process 1 to 2 here? Everyone, polytropic compression. This is what? Process 1 to 2, polytropic compression. And then process 2 to 3 is what? Constant volume heat addition. And then after the adding the heat, pressure reaches to the what pressure, guys, everyone? To the 80 bar. So this 80 bar will be which point pressure here? Everyone, this 80 bar will be which point pressure? 0.3 pressure is what? Our 80 bar. So this will be our P3. So now, guys, everyone, so before going further, what we are going to do? After this PV and TS diagram, means we have not drawn a PV and TS diagram completely. So before going further, guys, everyone, after just leave the 1 or 2 line, guys. Don't try to save the space, guys, everyone. Just leave 1 or 2 line, and after the 1 or 2 line, write down the names of processes: polytropic compression, this one, and process 2 to 3, constant volume heat addition. Please everyone add the names of processes, guys. Now guys, everyone try to see the scenario further after the writing down the processes. Now we are going to write down the given things, guys. Here we have what, everyone? Total 2 processes. So 2 processes means what? How many points with us? How many states? Point, instead of saying points, we will say states. So here process 1 to 2 means what? We are going from state 1 to 2, and process 2 to 3 means what, guys, everyone? Process 2 to 3 means what? We are going from what? State 2 to 3, guys, everyone. We are going from, so here 1 to 2 is one state. First state 1, second state 1 to 2, and third state is what, guys, everyone? 3. So here 1 to 2 means 1, second 2, and third. So here we will have what, guys, everyone? 3 state. So now what we are going to do? We are going to form a table. So always it is better to form a table, because means then we will not feel any difficulty to get write down the given things, guys, everyone. Means while during the numericals, if you want temperature of particular point, then we can easily get that temperature, pressure. Otherwise we have to search everywhere. So first of all, what we are going to do? We are going to form a table. So in table, first of all, what we will do? We have what? Total 3 points. So for each points, we are going to see 3 properties: pressure, temperature, volume. So first of all, what, guys, everyone? P1 for point 1. We will see pressure for point 1, then temperature of the point 1, and then volume of the point 1. Similarly, for point 2 also we will see. It is not necessary that they will give us all pressure, all properties, means all properties of point 1, all properties of point 2, they will give you only few things, but we will come to know that from this table which things they have given us and which thing is not available with us. So then for point 2 we will write down the same thing: pressure, temperature of point 2 and volume of point 2. Same for the point 3 also. If we have 4 points, then we will write down the 4 points. But here we have only 2 processes, so we have only, so P3, T2, and what, guys, everyone? V3. So in this way we have what, guys, everyone? In this way, what we have, guys, everyone? In this way, we have what? If you observe the things, guys, everyone, carefully. So in this way, we are going to form a table. Now I am going to read the question once again, guys, and try to write down the things they have given us in the question. So try to see the scenario here. Don't write anything. Don't do anything. Just listen the words carefully. So now, before going further, so air at a pressure of 1 bar. So this is what, our P1 pressure. So here 1 bar is what, everyone? What is 1 bar? P1 pressure. Now 1 bar means what? How much, guys, everyone? 1 bar means what, everyone? 100 kilonewton per meter square. 1 bar means what, guys, everyone? 100 kilonewton per meter square. So 1 bar means what, guys, everyone? 100 kilonewton per meter square, 1 bar. So always remember, 1 bar is equal to 100 kilonewton per meter square. And here in this chapter, our favorite unit of pressure is what? Kilonewton per meter square. So here we converted bar into kilonewton per meter square. This K is small, N is capital, M is again small. That is unit of a pressure. Now, guys, everyone, and the temperature of what, guys? 300 Kelvin. So air at a, so initial pressure is 1 bar. Initial temperature is what? 300 Kelvin. So here T1 is what, guys, everyone? 300 Kelvin, initial temperature. After that, what we have, guys, everyone? Is compressed in an engine cylinder from a volume of 0.3 meter cube to a volume of 0.2 meter cube. So, guys, everyone, try to see the scenario here. So this 0.3 meter cube will become what, guys? Our V1. Means this is initial volume 0.3 meter cube, and 0.02 meter cube what, we are going to do a compression up to this volume. So we are doing compression from what, guys, everyone? 1 to 2. So this is starting, compression is starting at this point, means our 0.1. So that will be V1 volume, and this will be what, guys, everyone? This will be what, our V2 volume. So that is what, a 0.02 meter cube. So V1 is what? 0.3 meter cube. Guys, check it. I have written correctly. Yes, 0.3 meter cube. And 0.2 volume is what, guys, everyone? 0.02 meter cube. So 0.2 volume is what, everyone? 0.02 meter cube. Try to see the scenario here. Very simple discussion guys, not that much difficult discussion. So 0.02 meter cube. Now the next thing is what? Index of compression. Now index of compression means what? Our N. So N is what? 1.52. We have already written here. So no, don't worry about that one. Heat is then supplied at a constant volume. So heat is then supplied at a constant volume means what? When we are going to 2 to 3, volume is constant. When we are going from 2 to 3, what is constant here? When we are going volume from 2 to 3, when we are going from 2 to 3, volume is constant. So can we say V2 is equal to what? V3, or V3 is equal to what we can say? V2, because 2 to 3 volume constant. So constant volume, so V3 is equal to V2. That is what guys everyone? 0.02 meter cube. So we got it what guys everyone? We got it what? V2. V2 is equal to V3, and until the up to what point we are going to add a heat guys everyone? Up to what point we are going to add a heat? Up to what pressure we are going to add a heat? Up to 80 bar. So we are going from what? Until the pressure reaches at 80 bar. Until the pressure reaches at what guys everyone? 80 bar. So this will be what guys everyone? Tell me. This will be pressure of what everyone? Pressure of 0.3. So this will be what guys everyone? P3 will become what guys everyone? 80 bar. And 80 bar means what guys everyone? 8000. We will multiply it by 100. I told you what is our favorite unit of pressure in this chapter? Kilonewton per meter square. And 1 bar means what? 100 kilonewton per meter. So 80 bar means what? 80 multiplied by 1000. 80 multiplied by 100. And we will get in what guys everyone? In kilonewton per meter square. So 80 multiplied by 100, we will get 8000, and that will be 8000 kilonewton per meter square. So we got it P3 in kilonewton per meter square. So always remember how to convert bar into kilonewton per meter square, multiplied by 800. So 1 bar means 100 kilonewton per meter square. So 2 bar means 200. So 80 bar means what? If you multiply 80 by 100, we will get a 8000 kilonewton per meter square. Now guys everyone, so these are the things they have given us. So before going further guys, this still we have not written the note. So now we have what they have given us what for air? Gamma. Guys see, they have given us a gamma doesn't mean that the process is isentropic. I told you guys, this is a property guys everyone. See, in every question we will get a value of gamma R. These 4 things everyone. These 4 things they will always give. Cp, Cv, R and gamma. So guys everyone, this is gamma guys, everyone. These 4 things are what? Property of that particular ideal gas. So whether process is isentropic or non-isentropic, gamma will be there. When isentropic is there, we will use isentropic relation. But don't consider, oh, they have given us a gamma. It means what? Our process is isentropic. For isentropic process, they will clearly mention process is isentropic. See, just have a look at this question 1 minute. I'm going to take that question so that you will have an idea. How does we identify? Question is what? Isentropic process. 1 minute. How does we identify question? Process is isentropic. See, in this question, just have a look. We will see this question also, guys. Don't worry. See here, if you read this one, compress isentropically. So they will clearly mention such type of things. We will see this question. We will see this further question in the next, after 1 or 2 lecture, guys, everyone. So if they are saying isentropically, means what, guys, everyone? If they are saying isentropically means what, guys, everyone? Try to see the point here, guys, everyone. If they are saying isentropically means what, everyone? It means what? We are doing isentropic compression. Guys, so for isentropic process, they will clearly mention like that. Otherwise, it doesn't mean that process is isentropic. For isentropic process, they will clearly mention isentropic like this. But here, our process compression is not isentropic compression. Here, compression is what? Polytropic compression. Because sometimes few students, what they will do, instead of here, they will assume, we have gamma. They will consider what? This is water. They will assume, isentropic compression. This is not isentropic compression, polytropic compression, because they have given us an index of compression. Gamma is what? Isentropic index or adiabatic index, but it is a property of that particular gas. Means whatever the process, guys, everyone, all these 4 properties, Cp, Cv, R, gamma, must be there, guys. all these four properties, Cp, Cv, R and gamma, what will be there guys? That must be there, everyone. Try to see the scenario here. So we have what guys, everyone? We have what? Gamma, R. So gamma is how much guys, everyone? Gamma is what? 1.4. See guys, everyone, sometimes I'm not writing down the gamma, but you have to write down the gamma 1.4. And R is what, everyone? How much value of R they have given us guys, everyone? Beside the gamma, 0.287. So R is what? 0.287 kilojoule per kg Kelvin. Don't forget to write down the units guys. Then after gamma R, guys, always we have what guys, I told you. We need always in every question, we need 4 properties guys. Generally, it is not compulsory, but always guys, what we will do? We will always write down all the processes guys, everyone. So means what? We will calculate all the 4 points properties guys. Means here they have given us only gamma and R they have given us, but Cp and Cv is not given. So before going further guys, everyone, what we are going to do? We are going to calculate Cp and Cv only at this step only. So what is the Cp guys, everyone? What is the Cv? Instead of Cp, we will calculate first of all Cv. So now what have we told guys, everyone? So we always calculate Cv. Means we should have all 4 properties guys. Cp, Cv, R and gamma. So Cv is equal to what, everyone? R upon what guys, everyone? Gamma minus 1. R is what? 0.287. Gamma minus 1 is what guys, everyone? Gamma minus 1 is what guys, everyone? 0.4. 1.4 minus 1. So if you do the calculation, what we will get guys, everyone? Do the calculation with me. Don't just sit ideally. Do the calculation with me. So if you do the calculation, we will get what? Cv 0.7175 kilojoule per kg Kelvin. So we got it Cv. Then what guys, everyone? Cp is equal to what? Gamma Cv. Gamma is what? 1.4. Cv is what? 0.7175. So if you do the calculation, what is the value of Cp? We got it guys, everyone. Do the calculation. 0.7175. 0.7175 into what? 1.4. So 1.0045 kilojoule per kg Kelvin guys. Capital K means what? Kelvin. So before going further guys, everyone, please add this discussion in your notes guys. Add this table and these given things, everyone. Please add this discussion. So everyone completed up to this point. Now try to see the scenario here further, what we have to do and how we are going to approach the further guys, everyone. So now see, everyone, this is the standard practice generally we will follow in every numerical guys, everyone. This is the standard practice generally we follow in the numerical. See what they are guys, everyone, what they are asking us in the B's first part, temperature after compression, T1, total work transfer, total heat transfer, total change in entropy. So whenever they are asking us such type of things, they are not asking us per kg basis. See this question that we are going to do the next second question after that question. See, if you observe in this question guys, everyone, if you observe this question guys, everyone, here they are asking us per kg basis. So here we have to take a mass 1 kg. But in this question, in this October 2010 question, they are asking us per kg basis, specific entropy. Means what? Here we have to take a mass as what? 1 kg. So here they have clearly mentioned. But in this question, if you observe guys, everyone, in this question, they have not mentioned anything guys, everyone. In this question, they have not mentioned anything. So always guys, always remember we need a mass. And how to get a mass guys, everyone, for that purpose, always have a look at the table. So if for any point guys, everyone, for any point, if they have given us all the properties, all 3 properties, whether it is a 0.1 or whether it is a 0.2 or 0.3. If they have given us all 3 properties, pressure, temperature and volume, whether it is a 0.1 or 0.2 or 0.3. So if they have given us all properties of any of these 3 points, then we can easily calculate the mass, guys, everyone. And whatever the mass at point 1, same will be the mass at point 2, same will be the mass at point 3, because our system is what? Closed system. That is what we have studied. All the processes in this chapter are what, guys, everyone? Are for what? Closed system only. So whatever the mass we are calculating on the basis of point 1, same for the point 2, same for the point 2. We will, instead of saying point, we will say states. State 1 or state 2 or state 3, guys, everyone. So here in this question, we don't have all properties of point 2. So point 2 is not useful for getting the mass. For point 3, we don't have all properties of point 3. We have only pressure and we have only volume of point 3. Temperature is missing. So temperature point 3 is also not useful for us. But if we have seen for point 1, we have what? All properties of point 1. We have pressure, temperature and volume of the point 1. So guys, everyone, so what we will do? We will use the relation, ideal gas relation, PV is equal to MRT. So we will say P1 V1. We can apply that relation to any point. So P1 V1, mass is the same. So for mass we are not adding anything, not any subscript, guys, and not any suffix. M, R is a property, so we are not adding anything to R. R, T1, P1 V1, guys, let me write down properly. P1 V1, P1 V1 is equal to what, guys? MRT1, ideal gas equation. So mass will be what, guys, everyone? P1 V1 by what, guys, everyone? RT1. What is the value of P1 we have, guys, everyone? P1 value we have what, everyone? 100. V1 is how much, guys, everyone? 0.3. R is how much? They have given us 0.287. And T1 is how much, guys, everyone? How much value of T1 we have? See the table, 300 Kelvin. That's the benefit of the table, guys. We can easily get all the things that we want. So before going further, everyone, guys, everyone, do the calculation, guys, with me. So please do the calculation with this video, guys, everyone. So if you do the calculation, everyone done the calculation, 100 multiplied by 0.3 into divided by 0.287 into 300, it will be what, guys, everyone? 0.3484 kilogram, guys, everyone. So we got it what, guys, everyone? Mass. So we calculated mass on the basis of 0.1, but it is applicable for what, guys? 0.2 also, means state 2 also, or state 3, because we discussed, guys, already. All the properties are what, guys, everyone? What we discussed, guys, everyone, means our system is what? Closed system, and for closed system, mass of the system is going to remain constant, whether it is 0.1, 0.2 or 0.3. All these 3 points are all these at 3 states. Mass of the system is what? Going to remain constant. So we have a mass. So before going further, please everyone add the discussion of the mass, everyone. Now, guys, everyone, after writing down this discussion, what is our target in B's first part, guys, everyone? What is our target? Temperature after compression. B's first part, they are asking us what, guys, everyone? Temperature after compression. Temperature after compression means what, guys, everyone? In B's first part, our target is what? Temperature after compression. But before going for anything further, what is, guys, everyone? First of all, we will try to draw the what, guys, everyone? PV diagram. After writing down all these given things, guys, up to mass, what we are going to do? We are going to draw the PV diagram. What is process 1 to 2? PV means what? Pressure volume diagram. That is what our A part answer. In A part, they are asking us pressure volume and temperature entropy diagram, TS diagram. So what is process 1 to 2? Polytropic compression. So polytropic compression means what, guys, everyone? If you observe the things here carefully, what will be the meaning of compression? Compression means what? Just have a look at the curve, guys, everyone, properly. Compression means what? See, have a look at the curve. Here what is going to happen, guys, everyone? See, compression. Pressure is going to increase, volume is going to decrease. So process 1 to 2 is what, guys, everyone? What is process 1 to 2? Polytropic compression. And we already told you, we already discussed, guys, how we will denote polytropic process. PV raised to the power what, guys, everyone? N. And N is how much here? 1.52, guys, everyone. N is how much, everyone? 1.52. So PV raised to the power what? 1.52 is equal to constant. Now guys everyone, then process 2 to 3, constant volume heat addition. Constant volume heat addition is what guys everyone? Constant volume process. If you remember constant volume process, just always guys, always keep these drawings in your mind guys everyone. This one for constant volume process, we have seen this one guys everyone. For complex constant volume process, let me minimize this little bit. For constant volume process, we have seen PV diagram. For heating, vertically upward. For cooling, vertically downward guys. We have studied all these things in much detailed way. So what will be the scenario guys everyone? So process 2 to 3, constant volume. Constant volume means what? How to draw that one on PV diagram? So that will be what? Straight vertical line upward guys. So we will have what guys everyone? 2 to 3, constant volume process. 2 to 3 will be what guys everyone? Constant volume process. That will be what guys everyone? 2 to 3. So constant volume means straight vertical line going upward guys, not going downward. If it is going downward means what? Constant volume cooling. If it is constant volume heating means what? Vertically upward guys, 2 to 3. If you draw one dotted line, we can draw guys. Always try to draw things properly guys, so that so here what we can say guys everyone? Volume of 0.2 is equal to volume of 0.3. So now guys everyone, before and TS diagram we will not draw at the beginning guys, because here we have a polytropic process. For polytropic process we will not draw the TS diagram in the beginning. We will draw the polytropic process TS diagram at the end of the numerical guys. I will always guys everyone, because for polytropic process we should know some things. So first of all guys everyone, we will draw the TS diagram at the end, at the end of the numerical. So before going further guys everyone, what we are going to do, just complete this PV diagram guys everyone. Where we have drawn the axis of the PV and TS here in PV part, complete this PV diagram guys, pressure volume everyone. Complete this PV part guys everyone. Now guys everyone, what is our target in B's first part here? Everyone, what is our target in B's first part? Temperature after compression. Temperature after compression means what? After compression, where compression is ending? Compression is ending at a point 2. So temperature after compression means what? They are asking us temperature of the point 2. So in B's first part, our target is what guys everyone? In B's first part, our target is what? They are asking us what guys everyone? T2. And how to get a T2 guys everyone? Very simple discussion. How to get a value of T2 guys everyone? Very simple discussion. See, how to get a value of T2, not that much difficult thing. So before going further guys everyone, see, we have what is process 1 to 2 guys everyone? What is process 1 to 2? Polytropic process. For point 1, we have what? Temperature, volume, pressure. For point 2, we have what? Volume. And we need a, for point 2, we need a temperature. So what is the relation between temperature and volume for the polytropic process guys everyone? What is the relation between for polytropic process? If you remember, for polytropic process, we have seen total 3 equation of state. This one. Guys everyone, total we have seen what everyone? We have seen total 3 equation of state guys, everyone. So what are the 3 equation of state? So between temperature and volume, this third one, only temperature and volume. So what we can say for process 1 to 2 in this relation? Guys observe the things here. So for process 1 to 2, guys observe the things here. For process 1 to 2, it is polytropic process. So what is relation between temperature and volume for polytropic process? T2 by T1 is equal to what guys everyone? V1 by V2 raised to the power what? Everyone n minus 1. So T2 will be what guys everyone? T1 into what everyone? V1 by V2 raised to the power what? N minus 1. So now what is the T1 guys everyone? What is the T1? T1 is what? 300. V1 is how much? V1 is how much? 0.3. V2 is how much guys everyone? V2 is how much? 0.02 meter cube. V2 is how much? 0.02 meter cube. N is how much? N is how much? 1.52 polytropic index. For that polytropic process, this 1.52. So n is how much? 1.52. N minus 1 will become what? 1.52 minus 1. So 0.52. So if you put these things into your calculator, 300 multiplied by all these things, put into your calculator, guys, everyone. Put it into calculator. So 300 multiplied by what? 0.3 divided by what? 0.02 raised to the power 0.52. So how much T2 we have? 1226.5597. So 0.5597 means what? Can we take 56? So we got a T2 in Kelvin, guys, everyone. So we have what value of T2 here. So this is what our T2. So if you are written at the top, our answer is approximately matching, no problem. So we have what, guys, everyone, in this way we got a T2. So before going further, please everyone complete this discussion. Now guys, try to see the further, guys, everyone, what they are asking us in which second part, total work transfer. What is our target in which second part, guys, everyone? In which second part our target is what they are asking us? Total work transfer. W total. What is our target, guys, everyone? Which second part? Total work transfer. Total work transfer means what? W total. And W total will be what, everyone? W122 plus what? W223. That is what a total work transfer. So how to get a W total, guys, everyone? How to get a W total? For that one we need a what? W122 plus what? W223. So what will be the W122? Process 1 to 2 is what? What is process 1 to 2? Polytropic process. Process 1 to 2 polytropic process. So for polytropic process, what is the relation of work done? We have what? Total 2 relations of work done. First is on the basis of what? See, polytropic process, guys. So for polytropic process work done, we have 2 relations. P1 V1 minus P2 V2 by n minus 1. Second one is what? MR T1 minus T2 upon n minus 1. So we have what? Total 2 relations. So what is that 2 relations, guys, everyone? W1 to 2. W1 to 2 what? So out of that we will generally prefer mass relation. MR. It is not necessary. We can use here both the relation because we have pressure. For point 2 we don't have a pressure. So we will use a second relation, that is temperature relation. MR. T1 is first, guys. Remember, not T2 minus T1. T1 minus T2 divided by what, guys, everyone? N minus 1. And how much mass we have calculated, everyone? In the beginning, before this first part, we have calculated the mass. So it is 0.3484. Mass is what, everyone? 0.3484. R is what? 0.287. T1, they have given us a T1. What is the value of T1 they have given us? 300 Kelvin. And T2, what value of T2 they have given us? They have not given us a T2. We calculated T2 in this first part. Now guys, everyone, before going further, always remember, I forget to tell you that, guys, always whenever we got any pressure and temperature, we always add that pressure and temperature in the table. Forget to tell you that one. What we have to do? We have to add this temperature into the table, guys, everyone, into the table. So generally try to add that temperature into table. So 1226.56 Kelvin, guys, everyone. Add this temperature into the table, guys, everyone. Add this temperature into the table. So after adding this temperature, everyone, now how much T2 we have? 1226.56. N minus 1, n is what, everyone? 1.52. N minus 1 will be what? 0.52. So W122 will be what? Everyone, what is W122? So before going further, 0.3484 into 0.287 into 300 minus 1226.56 divided by 0.52 minus 178 Check it guys, everyone. Do the calculation with me. 178.1682 kilojoule. Only kilojoule, not kilojoule per kg, because mass we have taken. If you have taken mass 1 kg, then kilojoule per kg. And what is W223 will be what? W223 will be what? What will be W223 process? 223 is what? Constant volume process. And if you remember our discussion for constant volume process, this constant volume process guys, everyone, for constant volume process, what is the relation of work done guys, everyone? There is a no motion in a constant volume process. That's why volume is remaining constant. So W will be what, everyone? W will be what? W will be 0. So W will be what? So process 2 to 3, W will become what? 0 kilojoule. Now W total will be what? W1 to 2 plus what? W2 to 3. W1 to 2 is what? Minus 178.1682. W2 to 3 is what? 0. So if you add this one, we will get a what? This W2 to 3 is a 0. So if you add, we will get a what? Minus 178.1682 kilojoule. And we are getting a minus value means what? Don't worry about getting a minus value. If you are getting a minus value means what? It means what? We are doing what? We are giving a work input. So we are giving a what? Work input. So at the end, instead of writing minus value, we will write down positive value and we will write down the unit, and then we will see, we will write down in bracket, it is what? A work input. What is it guys, everyone? It is meant by what? Work input. So before going further, please everyone, add this B second part discussion guys. Before going further, everyone, add this B second part discussion, that is W total. Now in B's third part, our target is what? Total heat transfer. In B's third part, our target is what? Total heat transfer. Total heat transfer means what? In B's third part, our target is what? Everyone. Total heat transfer. Total heat transfer means what? Q total. Q total will be what? Q1 to 2 plus what? Q2 to 3. That is what our Q total. And how to get that one guys, everyone? Okay. So before going further, everyone, we will see how to get a Q1 to 2 and all these things, everyone. Now what is our target here? We have to find out Q total. Q total will be what? Q1 to 2 plus what? Q2 to 3. Q1 to 2 is what? How to get a Q1 to 2? We need a what? How to get a Q1 to 2? What will be the relation for Q1 to 2? Q1 to 2 will be what? M. It is what? Polytropic process, and for polytropic process, relation of Q is what? Delta U plus W. So delta U 1 to 2 plus what? W 1 to 2. Delta U 1 to 2 is what? M CV T2 minus T1. Delta U 1 to 2, change in internal energy. W1 to 2 we have already calculated. How much we have calculated? See, minus 1 to, don't forget to add the sign guys. Here sign is very important. Minus 178. So minus 178.1682. So Q1 to 2. So mass is what? 0.3484. CV 0.7175. T2, how much T2 we calculated? 1226.56. See your table. Everybody should add this T2 in your table. I told you few minutes before. 1226.56. And T1 is how much? They have given us 300 Kelvin. 1 minute, let me write down properly. 300 Kelvin plus minus, so it will become minus 178.1682. So if you do the calculation properly, we will get about Q1 to 2. So please everyone do the calculation properly. 0.3484 into 0.7175 into in bracket 1226.56 minus 300 minus 178.1682. So if you do the calculation, if you will get about 53.4504 kilojoule. We got it Q122. What is process 223? Q223 is what? Constant volume. For constant volume process, what is the relation we have seen? MCV. Here 223, instead of writing, there we have seen MCV T2 minus T1. So here we are writing, instead of writing T2 minus T1, here we are going from 2 to 3. So that we will say MCV T3 minus T2. But what is unknown here? We have what? Temperature 3 is unknown. So before going further, add up to this point, everyone before going further, write down this discussion up to this point. Now guys, everyone, so now what is unknown here? Unknown is what? A T3. And how to get a T3? For that purpose, have a look here. See, we know generalized equation of state. If you remember, we know the generalized equation of state. What is generalized equation of state, guys? Everyone, if you remember, our generalized equation of state is what? 1 minute. What is generalized equation of state? This is equation of state for closed system containing an ideal gas. Everyone, P1 V1 by T1 is equal to P2 V2 by T2. So this relation is applicable for any process of a closed system containing an ideal gas. Any process, any point. So this relation we can apply. We are going to apply this relation to what? For point 1 and point 3. So what is the relation that we can say? P1 V1 by T1 is equal to what? P3 V3 by what? T3. Here we can add P2 V2 by T2, but here we are using, we need a what? A T3. Now how to get a T3? T3 will be what? If you arrange it properly, P3 V3 P3 into V3 into T1 divided by what? P1 V1. P3 is how much? How much value of P3 we have? P3 is how much? See the table. 80 bar means 8000 kilonewton per meter square. Don't take 80 bar. Huh? Take it in kilonewton per meter square. 8000. V3 is what? 0.02. Check it. 0.02. V3. See the table. 0.02. And then we have what? T1 300 Kelvin. 300 Kelvin. P1 100. And V1 is what? 0.3 meter cube. Huh? Check it. V1. P1 100. See the table. P1 100. And V1 is what? 0.3 meter cube. So if you do the calculation, we will get a value of what? If you do the calculation, we will get a value of what? T3. Everyone, do the calculation with me. 8000 multiplied by 0.02 into 300 divided by what? 100 into 0.3. So if you do the calculation, we will get a value of T3, that is 1600 Kelvin. Now we will get a what? Q223. What is Q223? M CV T3 minus T2. So mass is what? 0.3484. CV is what? 0.7175. T3 is how much? 1600. And T2 is how much? 1226.56. We will check it now. 1226.56. Correct? 1226.56. So if you do the calculation, we will get a value of Q223. Everyone do the calculation with me. 0.3484 into 0.7175 into what? 1600 minus 1226.56. So Q223 will be what? 93.3514. Unit will be what? Kilojoule. And we got it what? Q223. So Q total will be what? What is Q total? Q122 plus what? Q223. Q122 we calculated how much? 53.4505. 53.4505. 53.4504. 53.4504 plus 93.3514. If you do the calculation, we will get a what? Q total. So now we will do the calculation. 53.4504 plus 93.3514, and always try to do the calculation with me. If possible, pause the video and do the calculation. Is it matching or not? So you will have an interest in the lecture. Otherwise you will feel boring. So always do the things whatever they have mentioned in the, follow the every steps of the lecture. So we got it Q total, and we got it Q total positive. And if you remember sign convention for the Q, if you remember sign convention for the Q, in sign convention, what we have written sign convention? Everyone, what we have written sign convention? What is the sign convention we have written? See the things here. Somewhere we have written the sign convention. Here, if Q we are getting a positive. If we are getting a Q positive means what? Heat addition. If we are getting a value of Q positive means what? It is a heat addition. Now we got it what? So in bracket here we will write down heat addition. That is what our answer of what? This is what our answer of what? B's third part. That is total heat transfer. In B's third part, what they are asking us? Total heat transfer. The total heat transfer, and that is what we got it. How much we got it? 146.8018. 146.8018. It is approximately matching, and it is what? Heat addition. Up to Q223. Up to this step we have already written. So now I am going to do what? So before going further, please everyone start writing down discussion from this point P1 V1. Please everyone write down the discussion. So we got it now, Q total. Now what they are asking us in B's fourth part? Total change in entropy. So in B's fourth part, our target is what? Total change in entropy. How to get a delta S total? Delta S total means what? Everyone, what will be the delta S total? Delta S total will be what? Delta S 122 plus what? Delta S what? 223. So how to get a delta S 122? Delta S 122. What is the process 122? Polytropic process and polytropic process, we have seen two relations. So I will use first one, MCV ln T2 by T1 plus R into ln V2 by V1, because here value of the both the points. So we will use this relation. We can use another relations also, but that time we need a P2, and I think we don't have a P2 here. Yes, we don't have a P2. We can calculate, but we will not go into the calculation of P2. So we will first of all calculate what? Delta S122. Mass is what? 0.3484. CV is what? 0.7175. ln T2 is how much? 1226.56. T1 300. R is what? 0.287. Into ln means what? Natural log. Don't forget about this ln. Ln means what? Natural log. V2 is what? 0.02. V1 is what? 0.3. So do the calculation with me. So if you do the calculation, 0.3484 in bracket 0.7175 into what? ln of what? 1226.56 divided by 300 bracket complete plus 0.287 into ln of what? 0.02 divided by what? 0.3 bracket complete, and then whole bracket complete. We will get, if you do the calculation, properly check it out, everyone. 0.3484, 0.7175, 1226.56 divided by 300 plus 0.287, 0.02.3. So if you do the calculation, 0.08123 unit kilojoule per Kelvin. See the unit of the delta S, guys. Kilojoule per Kelvin. Then, so here we got it what delta S. Then similarly we will calculate what delta S 223 for constant volume process. We have seen the relation M into CV, ln of what constant volume process. Go to the constant volume process and change in. This is what our constant volume process. And for constant volume process, what relation of change in entropy we have seen? For constant volume process, go to the constant volume process. Last point of the constant volume process. Change in entropy mCv ln T2 by T1 in process 1 to 2. But here constant volume process is what? 2 to 3. So for 2 to 3, what we can say? mCv ln T3 by T2. Mass is how much? 0.3484. CV is how much? 0.7175. ln means what? Natural log 1600. T3 is what? 1600 divided by T2 1226.56. So if you do the calculation, we will get a what? Delta S 2 to 3. Do the calculation with me. 0.3484 multiplied by 0.7175 into what? ln of what? 1600 divided by what? 1226.56. 0.06644 kilojoule per Kelvin. So we got it what? Delta S 2 to 3. So delta S 2 to 3. So we will have what? Delta S total. So delta S total will be what? Delta S 1 to 2 plus what? Delta S 2 to 3. Delta S 1 to 2 0.08123. Delta S 2 to 3 0.06644. So delta S total will be how much? So 0.08123, 0.08123 plus 0.06644. So it will become what? 0.14767 unit kilojoule per Kelvin. So we got it what? Delta S total 0.14767. Check it whether we did any mistake. Okay, it is correctly matching, approximately matching 0.14767. So here, so before going further, everyone write down this discussion of the delta S total. Everyone write down this discussion of the B's fourth part. Please everyone complete this discussion. Now what is remaining in this question? What is remaining in this question? The remaining point is what? TS diagram. What is remaining in this question? TS diagram. TS diagram means what? Temperature entropy diagram. So that is what are remaining. And how to draw that one? I told you. At the end of numerical, if you have polytropic process, we will always try to draw the TS diagram at the end of the numerical. So how we will draw the TS diagram at the end? See, for process 1 to 2. Guys, everyone, see process 1 to 2. Delta S 1 to 2 is how much we got it? How much delta S 1 to 2? How much delta S 1 to 2? We got it what? 0.08123. Is it the positive value or negative value? 0.08123. It is a positive value or negative value? It is what? A positive value 0.08123. It is what? A positive value. So delta S 1 to 2 is what? We got it what? Positive value. So positive value means what? If you are getting change in entropy for process 1 to 2 positive, it means what? Greater than 0. Positive, it means what? Entropy of 0.2 means S2 minus S1 is greater than 0. It means what? S2 greater than S1. So if you are getting, try to see this point here. Very important discussion we are going. So delta S 1 to 2 is what? 1 minute, let me write down properly here so that you will get delta S1 to 2. What we got it? We got a value of what? 0.08123 kilojoule per Kelvin. So it is what? Positive or negative? We got it positive. It means what? Entropy of 0.2 is greater than the entropy of 0.1. Means when we are doing what? Process 1 to 2, then during polytropic compression, entropy of 1 to 2 is what? During polytropic compression, entropy of 1 to 2 is what? Increasing. From where we will come to know that entropy is increasing? From this point. Because delta S, and we will have another idea also. In 1 to 2, what is Q1 to 2? 53.45. Q1 to 2 is a positive. Q1 to 2, heat addition. 53 as we are getting Q1 to 2 positive, it means heat addition in 1 to 2, and due to heat addition we already studied entropy of the system always increase. What we studied? Due to heat addition. So one way, with the help of heat transfer, we will get a value of Q1 to 2. Another way is what? Another way is what, guys? Another way is what? With the help of change in entropy. So we can say. So here we will use a change in entropy. We can use heat transfer also. Both the way is valid. So from heat transfer also we can say entropy is increasing because heat addition in that process, because Q in 1 to 2 is positive. Or another way to say entropy is increasing, delta S positive. Delta S positive means what? Not a 0. I have written wrong thing here. Delta S 1 to 2 not a 0 is greater than 0. I should say greater than 0. And this is a wrong thing I have written. So delta S 1 to 2 greater than 0, and if delta S 1 to 2 greater than 0 means what? Entropy of 0.2 is greater than the 1, greater than the entropy of 0.1. So entropy 1 to 2 is increasing. Then what about temperature? Temperature of 1 to 2 is what? Everyone, temperature of 1 to 2 is also what? Increasing. And how does we come to know that temperature of 1 to 2? See, we calculated. So entropy in 1 to 2 is increasing because delta S 1 to 2 is positive. And positive means what? Greater than 0. It means entropy of 0.2 is greater than 1. So entropy of 1 to 2 is increasing. Temperature is also increasing. So here in 1 to 2 process, what we can say? In process 1 to 2, what we can say? Entropy is what? Increasing. We come to know that from here, guys, everyone. How does we come to know that? And temperature is also increasing. And how does we come to know that temperature is increasing? See the table. And then we will see that temperature is increasing, entropy is increasing. So what we can say? In 1 to 2, temperature and entropy both are increasing. So what we can say? See here. In 1 to 2, 0.2 is higher than the 0.1. 0.2 is higher than the 0.1. It means what? Temperature of 0.2 is what, guys, everyone? 0.2 higher than the 0.1. It means what, everyone? 0.2 higher than the 0.1. It means what? Temperature of 0.2 is higher than the 0.1. 0.2 is what? Right hand side of the 0.1. 0.2 is what? Right hand side of the 0.1. It means what? Entropy of 0.2 is higher. And that is what we want to show here. Now in 2 to 3, constant volume. And for constant volume, we will have what? Always higher slope, guys, everyone. Let me draw that one properly. 1 minute. I want to draw it properly. Here, for constant volume heating, slope will be always higher. That is what we have seen in our theory. So this is 1 to 2. And 2 to 3 will be what, guys, everyone? A little bit higher slope. So here we will have what? 2 to 3, constant volume slope. So constant volume slope is generally higher. Constant volume slope is what? Generally higher. So here 1 to 2 process is what? Polytropic process. How we denoted polytropic process? PV raised to the power n, constant. And 2 to 3 is what? What is 2 to 3? Always show this dotted points, guys, so that we can easily differentiate. And 2 to 3 will be what? 2 to 3 is what? Constant volume heating for constant volume process. We have already seen TS diagram for constant volume process. What is the TS diagram for constant volume process? We have seen constant volume heating. If you remember, this is what the TS diagram, going vertically upward. And here what will be the scenario? So heating is what? Temperature is what? Increasing. So what we are going to do, guys, everyone? So in 1 to 2, temperature entropy increasing, but here low slope because polytropic, but constant volume we will have a higher slope. Here also temperature and entropy decreasing, and for constant volume process we have already seen the curve, guys. 1 minute, instead of red pen I will use a green pen. Constant volume process we have seen already a standard diagram. Slope is in constant volume heating, temperature is also increasing, entropy is also increasing. We have seen this one already in our theory. So this is what our TS diagram. So before going further, everyone complete the TS diagram. We have already completed the PV diagram. Beside the PV diagram, we have left the space for what? TS diagram. We have just drawn axis of the temperature and axis of the entropy. In that one, complete this one TS, temperature entropy. Everyone beside the PV, complete this TS diagram. Everyone complete the TS diagram. So this is all about the question 1, that is from what? July 2010 exam question 1.